Swinburne University of Technology.
So we'll move on to the lightning talks now. So the order of the talks will be myself, then Neil, Bianca, Jan, Stephen, Lyndon, and then Hai. And they're 10 minutes each, 7 minutes plus 3 minutes for questions. And at the 7-minute mark, could the next speaker come up? So we'll announce the next speaker before each talk starts. And I'll be moderating myself, so please keep me to 7 minutes. So the next speaker will be Neil. So when I get to 7 minutes, Neil, you jump up and get your talk ready because we want to move through them. All right, so I'm going to talk about a virtual laboratory that we put online called the Theoretical Astrophysical Observatory. So this is a galaxy. Okay, hopefully you've seen one of these. These have billions of stars. And what we do here at Swinburne is we build models of galaxies, and not just one galaxy, but we'll build a catalogue of tens, hundreds of millions of them. And they'll all have different properties and different histories depending on how they evolved and the environment that they evolved in and so on and so forth. And then we use that to compare to the real universe. So with these virtual universes that we build, we'll create something like this, which is the distribution of galaxies, as if you were sitting down on Earth in our galaxy here. And so each one of these points is a virtual galaxy that we've built. And then you can compare that to the real universe. Here's 250,000 galaxies from a survey that was done about 10 years ago in Australia, the 2DF Galaxy Redshift Survey. And you can see that, you know, the large-scale structure, the cosmic web of the universe is reproduced in our simulations, which is really good. And so this information is really valuable to interpret the data. Just for context, there's 3 billion light years. And then we can make images of this. We can stick ourselves at a virtual telescope and look at our virtual galaxies, not just plot their distribution in space, but actually look at them. And so this is a virtual image that we've made of our galaxies. And then you can compare it to real images that are taken with cameras on, for example, the Hubble Space Telescope. So you can see how this can be useful. There's a cycle of building theoretical models, generating these virtual universes, taking observational data, comparing. And with the theoretical models, we know everything about our universe, so we can test ideas and explore and so on and so forth. So what we wanted to do was put this data online and make it available to the entire community. In the past, you would have specialist groups that would do this, and they would just work one-on-one, and getting this data was very problematic. It's becoming larger and larger. So essentially, we put it in a database down the bottom. It's accessed through a web form query. There are various modules that sit on top. For example, the light cone module takes a box that we simulate this in on the G-star supercomputer and changes the geometry to something that would be observed. That's a non-trivial thing. Build images, simulate telescopes, for example. And the nice thing is there's no SQL programming involved. We're trying to go for the lowest common denominator with astronomers. They don't understand SQL. And so just click buttons and you can get back your catalogs and multiple catalogs, multiple simulations. All right, so so that's what we're doing. Okay, and that's actually adding a lot of value to the community. So how were we able to do this? Well, it was fantastic. As part of an all-sky virtual observatory proposal to NECTA, we got funding for the Theoretical Astrophysical Observatory part of that at Swinburne. And this was funded by NECTA, Swinburne, and Astronomy Australia Limited. The project itself is a joint Swinburne Intersect Australia AL project. So Intersect Australia are an e-research company. And we had web developers up in Sydney and so on and so forth working with a team down here at Swinburne. The project was about 1.5 years. I don't remember the exact numbers, but we're talking of order $1.5 million, something like that, for the TAO part of it. And I think we all had about 4 or 5 FTEs involved. It varied depending on where in this development cycle we were. So it's kind of a serious project, which is wonderful because I couldn't do this by myself. I have no idea about most of the technology that really goes on to make that happen. And there are professionals and experts out there who do. So why should we not be working with them? So impact. And so just to highlight, this is what I want every speaker to go through and tell us your resources, your impact, what your long-term prognosis and what you want from Swinburne is. So impact, first 2 months, 4,000 page views, 700 unique IPs, 150 registered users from the international astronomy community, but predominantly Australian, or at least roughly half Australian. 70 universes were built in those first couple of months. Okay, hopefully these will go into publications, but that takes time, takes many months, sometimes years to write a paper. Long term, we have half FTE support through the end of next year, okay, to maintain TAO. And development continues with new initiatives, so we're continuing to seek new funding and continue to develop and everything. But in the long term, it's uncertain. We don't know. We don't know where the money will come from. We don't know if we can retain our software engineers, give them some kind of career certainty on long term. And to say that we're scared that we'll lose them because they are exceptional people and exceptional programmers is to be understating it. They are essential for the success of the project, and we need to keep them. So what do we want from Swinburne? We would love it if they underwrite the technical staff in between the surges in funding. When you get funding, it's wonderful. You feel like you've won the lottery, and then after a year or whatever, it goes away, and then you wonder what the hell you're going to do for that 6 months or a year in between. And it would be wonderful if we could provide some certainty to our developers and so on. Ultimately, personally, I would love if there was some center or similar in data-intensive research that we could go to, like Matthew described, and really we want Swinburne to help us build a community, a data-intensive research community here, and that's an initiative we have to drive, but with the support of Swinburne, hopefully we could make that blossom into something larger. So that's my time. Neil, could you come up? And so while Neil sets up, are there any questions for TAO? So the goal of these lightning talks is really just to give you a sample of what's going on. And so the more technical side of things and so on we can talk about in the discussion. Yeah?
During the project, did you find that you were able to get success from contributions to the project from others, like others in the astronomy community? Was there interest in other people contributing to this?
Especially with development, testing, like ideas. I mean, it's no point building something fancy up in the cloud and then nobody uses it. So the only things that have value are things that people will use ultimately. So there was a lot of consulting interaction with the community, and then when we started to build things, they would come in and they would start to use it, and they would give us feedback. No, that didn't work. I don't like that. And so on. So it was very interactive. It really has to benefit the community, I think. Ultimately, that's where the success will come from, and not from being funded, really.
Right, so I'll get straight into the next, which is thinking about e-therapy or e-mental health, an element of e-health. Although a lot of the work that we do in this area is relevant to health broadly, I think the central area has been mental health. Mental health is very important in terms of being something which affects people in their 20s, in their 30s, in their 40s, not just of late life in terms of health. So what we see is a lot of disability associated with that. And going beyond the sort of usual format of face-to-face intervention, there's been interest and expertise at Swinburne in developing self-help based interventions which can be delivered online, in an online environment. And I suppose the old story about this is that this is very helpful because it increases access. A lot of people don't seek help, and some people may be inhibited by living in a remote area. Some people may be inhibited by the sort of personal nature of talking about health. But as we are thinking about the growth of technology in everybody's life, there is more and more usage of technology to start managing health problems. So if we look at something like the growth of mobile apps, health apps are shooting up at double the rate of other types of application, and within that mental health is probably the main area which you can point to. So we've had a research centre that's been looking at e-mental health for a number of years. This has been something which has used sort of government tenders in providing an e-mental health service in order to leverage off that to get research funding, including NHMRC funding. what we have, this is to give an example of the current projects that we've got. So we have a tender from the Commonwealth Department of Health to be running an online self-help with online therapist support. So what this kind of looks like is that people can log on and access self-help materials, and then they'll get an email from people with providing support. And we also have another project called SMART, which is a research-funded project, which is more about how can we integrate online resources into healthcare provision. So looking at how we can have things on tablet computers which health professionals can use. And as well as that, we also have some smaller projects which we're running, and mobile app development. So this gives a bit of an overview of the activities which we have. To make this a bit more concrete, so this is Mental Health Online. These are some screenshots from that. What we essentially have is a content management system, and also we have people will register and log on, and it will record data. So there's a database there as well, which is managing information. And in addition, we have communications, which at the moment is about email, but we are developing more real-time therapist communication. So we're in the process of piloting at the moment things like Skype-style video chat, so there can be real-time communication with people in an online environment, and additionally having a sort of virtual reality type environment for interacting with people and to see how that goes. The SMART project that we are also running, which is looking more at how things can be on a tablet. So we have issues there around how can things fit into an interaction with people. So there's a face-to-face interaction. What do things look like on a tablet? How does that fit in to an interaction? This is something that we're collaborating with a number of health providers with. So this is a big project. And there are some exciting things about this. I'm going to do the risk in these 7-minute talks of actually trying to play a video and getting it to work. But some of the exciting things about this are actually presenting new ways of working with people.
For me, I don't think I would be the person who I am today if I hadn't been through every single thing I had in the past, because that's what's made me today, what's made who I am today. And I'm grateful for who I am today, and I don't think I would change it for anything in the world. I think it's experience that's what makes me.
Something we're finding really interesting is actually using the potential for using multimedia in this environment. And what we've traditionally done in healthcare is be sort of working with people by giving advice or asking people questions and guiding them and thinking about things. We actually have a lot of capabilities here to think about how we can start delivering health interventions differently. So that we can start using, can people learn from modelling from other people? Can people learn through social networking, through commenting with each other? So a lot of the research directions that potentially we see is actually getting a science around how technology can fit in to healthcare and promoting behaviour change. And that applies to mental health as well as physical health problems as well. Okay, so as well as that, we've got growth, as we say, in the mobile application area. So, and hopefully we can start developing that more as well. Now, okay, let's think about some of the challenges that there have been. I guess this has been something which has been within a research centre operating, you know, not as integrated as it could be with the broader university. And from that point of view, we are sort of often struggling with some of these issues. One of the issues is around vendor management, dealing with external vendors who we've been reliant on that don't always fit with research timeframes and so on, which can create an awful lot of problems. We also have an element here in which we've been able to get big money from government tenders, but that's been primarily for providing service type delivery, which isn't quite the same as the university's core business for research. So it's getting a balance between how service and research can fit together. As well as that, because of the types of data that we've got personal data. So we have issues in terms of legislation requirements around how we store health data and think about privacy needs and security needs with that. So currently we're not storing any of this data here. We're using an external hosting provider, Macquarie Telecom, for data to manage some of those issues. However, look, I think what we have with the faculty restructure, the whole sort of new energy in the university is actually an incredible amount of opportunity with this particular area of research to be thinking more broadly and working with other people. Certainly, so within the faculty, we're in health arts design, we have an increased focus on health, we have new energy with forensic populations, we have a focus on ageing, we also have potential for working with other schools, thinking about social research, thinking about design. As well as that, I'm hoping that we can get more collaboration with other parts of the university as well, and in particular thinking about, can we start to look at increasing our capacities to be building things in-house and increasing our capacities to be managing some of these data at Swinburne. So I'm hopeful for that, and get in touch. Thank you. Sure.
Do the privacy and so on issues
and legal issues with medical data add to the financial cost of putting these things online? I mean, is this an additional financial burden that we should deal with?
Yeah, so the question about whether there's additional costs because of the nature of private data and health data. Well, certainly, I mean, we're having to pay for external hosting essentially, so that does create a cost for that. So we've actually got quite sophisticated hosting which we're paying for from a government tender, but then that creates a question about, well, what happens when we haven't got that ongoing funding for being able to look after those things?
So is that a threat then,
Yeah.
that in a few years' time that funding runs out, and is that a need that you need from a university
Yeah.
to underwrite the continuum?
Yeah, absolutely. So that's one of the key things that which would be important in terms of this.
So you must have a lot of people that are actually dependent on you providing a service for their mental health well-being in the future. Does that create an additional pressure to sort of feel like you sort of, like if you're a psychologist and you've got 100 patients that depend on you, I know it's very difficult to retire without sort of hiring somebody else to take over the business. But with this, if you were dealing with 50,000 clients, suddenly disappeared, I imagine that it's almost like you're abandoning them.
Yeah, sure. So that's yeah. I mean, that's kind of one of the issues with the service stuff. I mean, it kind of fits when you have things as a discrete research project. It kind of puts those parameters around that, so that makes it more manageable with those things. But that can be one of the issues with that. Although ultimately, it's working with with the more service delivery. It's working with the federal government, who that's their kind of concern. Yeah.
Well, hi everyone. My name is Bianca Phillips. I'm a lawyer and I lecture here at Swinburne University in law. Okay, today I'm going to be talking to you about law in the age of telemedicine, which is quite fitting because Neil has just discussed the Mental Health Online project. Okay, I'm going to talk to you about the project that I've been working on, its purpose and audience, the resources that I've had available to me, or lack of, long-term development, and what I hope to do in the future. So I've been looking at the current laws surrounding the governance of telemedicine practices, particularly privacy and security governance. And when I talk about telemedicine practices, I'm referring to the electronic storage and transmission of health information. It can include many different areas, email, telephone, vital signs detectors, health applications, webcam consultations between patient and health provider, and internet advice. And I'm not sure if you've recently been looking at the news, but there is a new online doctor service which has just been launched, enabling patients to log on select the medication that they're interested in purchasing, and receive that medication after completing a questionnaire. So it's quite a big area. There are some telemedicine practices which are more contentious than others, and that's what I've been looking at through my research. But the focus has mainly been on privacy and security governance. Now, in my work, I've been making recommendations for the amendment of legislation. In March this year, we saw some major amendments to privacy law in Australia, and as a result, any researcher who's embarking on any research within the e-health space and other areas really needs to make sure they're aware of those changes. My research has been published in LexisNexis Australia, which is a legal publisher. So the aim of the research is to better facilitate an understanding of the legal aspects of storing and sharing health information online. And prior to my research, there was really minimal research in the area of telemedicine and the law. Now, there's quite a lot of research out there on privacy law, but there was not much on telemedicine and the law apart from an Australian Law Reform Commission report which was written a few years ago, which was quite a big research project. Okay, my intended audience include patients, physicians, researchers, organisations maybe hosting data and also embarking on e-research projects, and legislators. I've actually had no funding. I've had assistance from an external supervisor from the University of Melbourne Law School. That's where I've been doing my research. But really the purpose of coming here today was to introduce myself to the Swinburne research community and to let you know that I am doing research in this area if you're interested in discussing with me further. In terms of long-term development, my aim is to continue legal research in this area and to monitor future developments. I'm consulting on the side of doing my legal research in order to assist companies embarking on telemedicine projects. I also aim to work alongside health experts to conduct scientific research regarding the effectiveness, safety and cost effectiveness of telemedicine services. Now, in relation to the projects at Swinburne University at the moment in the e-health space, there's actually no linkage there between my research and what Neil and his team have been doing. So we're not affiliated. And obviously that's important for me as a lawyer and researcher to be objective and not involved with any other party. So if researchers are interested in contacting me, if you have any concerns about the research that you're doing and the privacy and security implications, please feel free to contact me and I might be able to refer you on to a legal practitioner specialising in this area to assist you and give you some legal advice. In terms of outcomes, I don't really want to focus on that, but if you're interested, a couple of points. If you're at all involved in the storage of health information or any information really, you need to be aware of the Office of Australian Information Commissioner security guidelines. So that would be one point, the Office of the Australian Information Commissioner security guidelines. Also, there are there's an Australian Government Security Manual which you should obtain and have a look at. And the complex part of storing data online is that there are so many different state, territory and federal laws that you need to comply with. And at the moment, because the federal laws have just changed, there is some inconsistency between state and federal laws, which makes it even more complex. I really truly believe that you cannot dispense with face-to-face consultations with patients. That's really critical. And we can see that based on medical tribunal cases that have gone before tribunals and committees based on the conduct of practitioners when they were providing advice solely on the telephone. So it is important that there is some aspect of face-to-face communication, and getting that balance right is going to be really critical. Anyway, that's all for me. If you have any questions, I'm happy to answer those.
Bianca, you said it's best to have face-to-face advice. But we've got researchers, for example, who are conducting research, but in psychology or wherever. But occasionally they've got to deal with a real situation. Someone's falling apart. Now, their position is not as a counsellor or as a treating professional, but as a researcher. But they've got to respond to that. I guess there's a complication there if they have to provide therapy almost while they're doing the research. Can you comment on that?
So are you saying that as a researcher as well, you've got obligations in terms of?
Well, I mean, a psychologist, for example, would be bound by the APS code, that they've got to provide duty of care to people. But they're primarily a researcher in these projects. But they've got to deal with somebody who has a need. And you said it's best to have face-to-face. But let's say the thing there is that you've got researchers wearing a researcher hat, but is suddenly being called upon to provide counselling as well.
Well, that is complicated, definitely, but, regardless of the role of that individual, they still need to be providing some form of face-to-face communication. That's just based off the lessons that we've learnt from these medical tribunal cases where, doctors and others providing advice on telephone, it just hasn't been considered acceptable conduct. And there's been about 13 cases that have gone before medical tribunals and professional committees. So really the best thing to do if you're a researcher or your advisor in the health space is to make sure that you're combining any telemedicine communication with face-to-face consultation. And the medical tribunal cases have stated that you've got to keep a contemporaneous record of your communication with the patient and store it on the file. And I know that seems common sense, but when you're giving advice on the telephone or in email, you may not think to, store that onto the patient record. You really need to keep good records of what you've said to the patient. It's really important. Hope that helps. Okay, thanks.
Well, in general, I don't think I need that, but yeah, just in case. Good morning. My name is Yun Yan, and I'm a computer scientist. So in a lot of cases, I'm supporting e-research instead. I will leave this over here so you can use laser or moving around. So I work at School of Software Engineering, Software and Electrical Engineering. I'm still getting used to this new faculty and the school structure. But given what I'm going to talk about, basically, I do a lot of things. Today, I only focus on one thing related to big data, related to cloud computing, both Matthew and George mentioned before. So sometimes we have to ask, how big is the big data? Whether it's 1 terabyte, 1 petabyte, or 1 exabyte, or things like that, right? So no matter what happens, at the end of the day, you need to pay for it, right? So the cost is what I'm going to focus on today. So we're talking about data storage for cloud computing. I'll mention cloud computing just in case someone doesn't know. So try to understand the cost trade-off. We had a book about this, but it's given what we are going to talk about it within 5 minutes, so I'll carry on. So cloud computing doesn't really matter whether you know it or not. I can tell you very briefly. Everybody knows to turn the tap, you got a running water. You switch it on, you have the electricity. Similar thing for cloud computing. You don't need anything. For you, basically what you need is a web browser as an end user. And everything else, computing power, CPU if you like, storage, network, everything is somewhere there. Believe me or not. It's somewhere there, you can use it, right? So that's what we call, in a very plain language, cloud computing. You just believe everything is somewhere there. I can show you where it is. This is the Google data center, which is about a football or soccer field size. 4-story building, right, with all the cooling system, the CPU, storage inside of it. You can use, that's just one. Google spent $1 billion each year to build these kind of things. So you can imagine a lot of computing power over there you can use. But of course, we might say, oh, we have our supercomputer. Why not bothering with cloud computing? Certainly you can think along that way, but whether the supercomputer is enough for you, especially when Matthew talked about it, it's an institute and many people will use it. Probably our supercomputer doesn't have enough capability to do this kind of thing. So we can burst out if we need more, and then we can come back if we don't need any extra. But the key issue is pay as you go, right? So that's why, in theory, you don't need anything. You just need a web browser, right? Hey? And a credit card, of course. The cost is always there. But if you build your own supercomputer, if you turn the electricity on, and you always pay, right? So no free lunch, Darren, no free lunch. But we're talking about the cost-effective way of doing this. When we talk about big data, we talk about a huge size of data. I put on some data sizes. Of course, everybody knows the first line. Coming to the second line, exabyte, zettabyte. At the moment, we're talking about this scale, right, zettabyte. I believe in a decade time, we'll talk about yottabytes afterwards. Right? So that's a lot of data we are talking about. And certainly, the Moore's law is something, every year or two, the data size will be doubled. That's what published a few years ago on Nature, right? So that's not what I said. It's a common belief. The problems I have, right? I know, a lot of people using Parker's, especially Matthew, using Parker's radio telescope, square kilometer arrays on the horizon. Is that already functioning? Not yet. So you have a lot of data over there, right? Putting them down, and George mentioned if you transfer petabytes of data across the internet, of course, it's going to take months. But we don't do that with DHL or Express, the disk over there, and they can upload very quickly. But what we are talking about is not the raw data. If you delete that, within 7 years, you have to get a written permission. Is that still true? But I'm talking about generated data. From the source data, you do a lot of calculation. That's what e-research is about, right? You do a lot of calculation. You generate data along the line. For this kind of data, how can you cut the cost down? As Darren said, you have to have credit card, but you don't want to pay more than you should be. Right. In that case, we try to minimize the cost to store the data, generated data. So the work we have done, basically I put a couple of problems or challenges, if you like. Which data should be stored in the cloud or anywhere, right? What is the minimum cost benchmark, right? You don't want to pay more than you should be, right? And significance of the minimum cost benchmark, right? There are a lot of issues over here. So basically what we have done, theoretically, we find out the minimum cost possible. Right? That's called benchmark. With that benchmark, if you are end user, you say, okay, I don't want to pay more than that. Right? Or if you are service provider, like cloud service, cloud computing service providers, they can make the profit based on the minimum possible cost. Right? So in that case, you might say, okay, $10,000, will you do it? If the minimum cost is $6,000, yes, I'll do it. If you bargain very hardly, say, okay, can you do it for $3,000? They will say no. Right, so you can imagine the significance of doing that. So all this kind of research funded by ARC Discovery previously, and then followed up by a linkage project. So it's a lot of fun. So I'm just showing you a diagram. Yeah, I'll finish in 2 minutes, no problem. So this is a diagram just to indicate all different strategies of storing generated data. Okay, you can imagine, if we don't store anything, right, the cost is like that. If we do something smartly, right, the cost can drop down all the way to here. That's the benchmark we have. That just gives you an indication of the lines which you can see the cost. We even did a simulation with Pulsar. I don't know. I didn't tell Matthew before. But basically what you can see is, right, given what we had, probably nowadays or previously, I think, you don't store any intermediate data, right, except results and the raw data. So that would cost this much. If using our strategy, it dropped down by 60%. Whether you like it or not, it's up to you. But that's what we have. So that's pretty much all I need to say. In terms of what I ask, what we need from Swinburne, I think I coordinated a Swinburne leaf-like proposal led by our Dean, John Grundy. So hopefully we can get our own cloud test bed so we can do all sorts of torture over it rather than using commercial cloud service providers that prevent us from doing a lot of things we hope to do. So hopefully the grant can be considered and be funded. Thank you very much. I'll leave this here so you can use this.
So questions for you?
So I have a question.
Okay, go ahead.
If you could repeat it for the mic. So who does the work here? So
okay.
do you hire software engineers? Do you use postdocs or students? Do you do it yourself?
It's funded by ARC, so you can see there are a few, a small team, including myself, a postdoc, and a software developer, so a PhD student as well. So we have a small team doing this kind of thing all the time. Hopefully ARC can still fund us, or Swinburne can fund us in a different way. Matthew.
So if we had 2 petabytes of data that Swinburne wanted to store, would you recommend that we store it on site or in the cloud?
Well, if you have your own gear, why not? If you don't, you can put it on cloud, but we try to give you the minimum possible cost to store on the cloud. But you still need to pay, unfortunately. That's just the way it is. But we had we had an estimation about using Parker's stream data. If we put all the raw data on Amazon Cloud, it can cost $5 million each year. And it's growing all the time. But certainly you don't store all the raw data directly from the Parker's radio telescope. You always filter out some noises and so on. Based on my understanding, I could be wrong because I'm not doing astrophysics. But basically, you can certainly shrink the data significantly with filters and with our strategy.
Okay, thank you.
All right. Thanks for that.
Thank you.
Our next speaker is Stephen.
Hello, can everybody hear that? Yep. I was in a really silly mood when I wrote this, so I might be a bit flippant, and I've got to run off to a meeting at 12, so if you want to chat to me, you'll be able to find me through the usual methods. Oh, and I didn't follow the template because I missed that email, so this is different. The brief we got, so can someone give me a 5-minute warning as well? Yeah, great. The brief we got was to go and find redevelopment precincts in the suburbs of Melbourne and Perth, because cities are expanding. We want to utilise the existing land a bit better. So we wrote some software to identify the lots that are going to be demolished and you could potentially amalgamate into a nice little village. Those blue lots there are the ones that you could start to make little villages out of if you had the legality of amalgamation sussed, and if you had money to buy it, and if you got all the local people to sell you their land. So we've done a lot of we've got an awful lot of social and geographical spatial data in there to try and find out where those places are. So that's the first thing. We wrote this software. It's all right. And it's getting implemented by Oren, because I think Matthew was talking about the life of software after it's developed. So we've incorporated that through a third party. With Uni Melbourne and a few other people, we're starting to build a 3D version of that, where we're going to be looking at allow users to build a 3D precinct and get economic sustainability feedback, how much traffic, how much extra waste, how much it's going to benefit people who sell their land, what can you put there, etc. So 2 bits of software. Because I'm over at the Institute for Social Research, we also do a lot of social stuff over there. So we're doing the economics of what will happen when you sell that land, sales to development analysis, what extra sustainability you can put in there, how much money you can save over time. I do a lot of community engagement, like just chatting to people about what they want to see in their community in the future. That's been fairly revealing. And we're also doing a lot of legal work, analysing how to go about doing this for real. So the product of the software beforehand and this is going to be a manual for the Department of Planning to actually go and do this for real in Melbourne, Perth and Christchurch. We also make a lot of graphs. This is just to show you that social studies can do stuff with maths. And we make a lot of tables, and they're great. We also have the potential to develop all of our algorithms and ideas into tools and online tools. We can start to publish this stuff. We just don't have the capacity to do it at the moment. And I am sick of being asked to develop websites for people. That's one of the things we need. The main issue I have with all this is data-wise, it's ridiculous. For those 2 pieces of software, I've had to gather 40 different data sets. Let's say each one has roughly 40 fields in it, 1.5 million rows, i.e. the number of houses in Melbourne. The data is entered terribly because it's usually captured from local government sources. I've said it there. Sometimes X is Y, up is down, etc., etc. So to go and clean all that data takes an incredible amount of time, whereas algorithms do exist for cleaning this stuff automatically. It might be nice to have some resources to do that so we can start to get complete metro coverage into these things. And another thing is to do something like walkability for a city can't be done on a single machine. It has to be done local government by local government. We don't have the capacity to do that yet. So it might be nice to get some database experts to show us how to elegantly program our queries a bit better. Another issue I'm having is to get all that done, I've had to go around cap in hand to all these different people. And I think we've got about 2 million all up for this project. So it's a good sized project. It's in 2 countries. It's over a lot of different places. It's going well. But because of all the stakeholders and because we're dealing with data from many different states, many different departments, we've had to mush all this together into a usable form, which isn't brilliant. But because we're actually doing it, as opposed to just whinging about it, we're starting to get there. And other academics and government agencies are starting to follow us. Like we're in the metro planning document that just came out. Not by name, but we've got a few clauses in there. So by actually making this software, as opposed to saying it can't be done, we're dealing with the issues that are real. How to get 2 different data sets that don't go together regarding, let's say, 2 different ways of calculating urban density and meshing them together into a way that can be used all over Australia. The architectures are being reused, algorithms are being reused, but because there's so many partners, the IP is so diluted that no one can actually make money off this. Now, as a social scientist, that's great because society benefits and everyone's happy. But there's always a business head on your case somewhere saying, what's in it for me? I gave you all this cash, how can I on-sell this? Swinburne can capitalise with this stuff by providing a few more resources to do any of what I just said, particularly showing how to get academics a path to market in terms of developing a product or an algorithm that other people can use. Students don't recreate the wheel, and we start to get some IP. Thanks. In conclusion, at the Swinburne Institute for Social Research, that's a plug. There's a lot of multi-dimensional, sorry, Doctor Who reference there. What's the term? Multidisciplinary, thank you. Lots of multidisciplinary people there. They are actually multi-dimensional as well, I'm sure, at least 3. But to unite them all and to give them some sort of path to market, there has to be a pathway for development. Otherwise, you're just going to be free-floating in your own little academic universe and have no formal way to move forward. And that's it. Oh, and the last thing is, I stole this slide from Peter Newton. Any questions?
Oh. Sorry, the next one. That's the second last. So it needs overarching IT and administrative support to develop and publish the tools we can produce. Do you want to just elaborate on that? Like, what would you like to see?
I would like to see some centralised programmers, centralised web developers. I'm always centralised, I mean they belong to the uni. And there's a formal process for approaching them, and they will show you how to go about developing your thoughts and ideas into something coherent and concrete. I'd like to see front-facing servers so we can develop our own databases and present them online. Maybe a test server and then a real database so we can deliver these things to the public. I'd like to see another organisation looking at a path to market for consultancy so we can then reuse those tools, reference them in the real world. And then I'd also like to see some postgraduate students getting real-world training in this stuff. Not just training, but getting paid to do it, because if they don't get paid to do it and their ass isn't on the line, if they're not going to get absolutely destroyed by failing, I don't think they're really going to learn. You can teach PhDs to do anything, but until they actually get out in the real world and are going to be hammered by a boss, it's not really going to sink in. So I'd like to see those. I'd love to be around this afternoon to discuss this further, because I've got a lot of ideas for this, but unfortunately.
So in one sentence, how do you do it now? Is it just opportunistic, or?
No, you keep going with this. You get a small team of people in each faculty or school who are trained in how to get those ideas up a ladder into a product. So they'd have to be IT experts with expertise in an area.
Hi everyone, I'm Lyndon Walker. I'm from the newly formed, this might be the name of it, Department of Statistics, Data Science and Epidemiology. I've been really pleased. There's been talk about statisticians this morning and how great and useful statisticians are. And we are. We're really useful and lovely and helpful. And there's a few of us here in the room. Do you guys want to wave your hands so that people can come and talk to you? That's going a bit far, but and we are very eager to collaborate. And so I'm here, I'm going to talk about a few e-research projects I've been involved with previously in New Zealand, not here at Swinburne, some of which I think there is potential for Australian versions of, and I'm also going to mention a few other things that me personally, I'm interested in collaborating on, but during question time, my colleagues may shout out other things that they are also interested in. So, if you hadn't noticed from the accent, I'm from New Zealand. When I say New Zealand, you really do notice it. And I did my PhD and was a research fellow at a social sciences research institute at the University of Auckland. They worked really closely with an e-research centre at the University of Auckland. So the discussion this morning about an e-research centre I thought was fantastic. The work that I did, I've got 3 bullets there of different things I was involved with, couldn't have happened without high-power computing resources and programmers that could actually talk to the computer and talk to the researchers. And so the researchers could come up with ideas, but didn't need to know all of the ins and outs of the computing to be able to turn them into something useful. So the 3 projects I have listed there are in order of my least involvement to most involvement. I'm very interested in social simulation. So that's simulation where you've got people or agents that are representing people and they're doing particular things and you're trying to look at patterns of what's happening based on what they do. So the first one was more of a healthcare project. We took data from the census, we took data from several health surveys, and what we wanted to do was simulate people aging and how they would use the healthcare system as they aged. That I had only limited involvement with. I know there's a few health research people here. I can fill you in and certainly point you to people that were doing that. Second and third one I was much more involved with. This was using census data, looking at interrelationships, particularly around ethnicity. Firstly, at a household residential level, so looking at ethnic patterns within suburbs. Do people tend to congregate into suburbs in patterns of ethnicity? And if you set up a simulation model and you give people particular preferences, rules that they move suburb, move house by, can you recreate that? The project, the third one there, the marriage markets, was actually my PhD. And with that one, again, what I was trying to do was look at recreating patterns that were appearing in census. I had multiple sets of census data, so I could set a simulation based on one census and then compare the output to the next one. And I wanted to see whether by giving people particular preferences, particular rules, this is how you might choose a partner, those decisions that an individual makes, could they create a societal level pattern? So those are some of the bits of e-research. The grid computing component came with the, particularly the marriage matching one, where you had hundreds of thousands of people looking and evaluating lots of other people in their communities. So there was lots and lots and lots of decision making all happening at once. Running it on a single computer took days, if not weeks. But with grid computing having lots and lots of cores, you could run a whole lot of things all happening simultaneously. So that's what I have worked on. I'm very interested in carrying on with the census-related and also Hilda data, because we have Hilda data here, using that as a way of populating simulation models. So using that as a way of giving empirical information to a model, also incorporating sociological rules, looking for patterns. Two other areas that I am interested in is statistical computing, so other ways we can use the grid, use supercomputer, and also data archiving. So when we do collect data, particularly data that we're spending a lot of money collecting, how can we make that available, make that useful, get that up in the cloud in a way that other people can use it, while still staying within the rules of ethics. And just got flashed the sign, and that's pretty much everything I wanted to say.
Questions?
A couple of questions, and I guess revolving around the sorts of things that people are asking about the resources that they need. And coming to one of the things you've got up there, you said that you've switched to grid computing.
Yes.
By grid, you mean parallel?
Yes, so a lot of kind of multi-thread, multi-core, used a lot of evolutionary algorithms, so a whole lot of the same simulation running different parameters,
sure,
searching a parameter space.
Yeah, so obviously that required some software development to go from something that could run in a sort of serial environment to something that could run on a multi-node computer.
Yeah.
And who did that?
So that was via the Best Grid people at University of Auckland. So they had a 80-core machine sitting there, which, given there's 4 cores on this one here, is not really as much as it used to be. I was writing my software in a mix of R and Java, and then I had people there that I interfaced with who would set up Unix scripting and putting it up onto the cores, off the cores,
so you
that
had
kind of thing.
basically external programmers who were looking after that.
Yep.
That software development.
And I mean, that's kind of my sticking point here is I can write a simulation, but actually that kind of spreading across cores, splitting things into threads, bringing them back is just...
And that's particularly challenging probably because they also require some understanding of the data. They can't just blindly go and...
Yeah, I mean, I think that's where Matthew was talking about good programmers and not so good programmers, the ones that can listen to what you're trying to do and go, yeah, that makes sense to them, and then they can kind of turn it into Unix scripting magic.
Okay. Great, thanks for that, Lyndon. So last speaker before coffee is Haivu.
Thank Darren. Can you hear me? Okay. Good morning, everyone. I would like to talk to you about the research that we are doing here at Swinburne in intelligent transport systems and how we're facing with the data that we have got. So this is the motivation slide. The data that's been predicted in here from this report is quite old. So this was published in 2007, but it does predict that in 2020 we will have in around $30 billion of avoidable costs, social costs that caused by congestion. So the congestion here, I'm talking about the traffic congestion that most of us, or maybe all of us, experience in some way. So currently we're tracking above the Midland line. So currently we're looking at about 12 billion for this year as a avoidable cost. So this cost includes the time that you spend in the traffic that avoidable. It also extra vehicle operating and pollution costs. So in fact, we will be actually checking the red line by 2020. So for that, what we have here at Swinburne is a partnership between Swinburne and VicRoads. So VicRoads is a government agency who operate the road networks in Melbourne and in Victoria. What you see on this slide is a system that they currently use to operate our networks, so essentially traffic lights. So this is the particular intersection that right here at the corner between Burwood and Grand Ferry. And this diagram here showing the phase of green and red in the cycle of the traffic cycle time. So what happened here is that at each of these outgoing lane at the intersection that has traffic light, they have the loop detector that that record the data. And what I'm talking to you today is about the use of that data, utilize that data to improve on the situation that we have on our road networks. So to appreciate that, let's looking at some data. So VicRoad essentially looking after 22,000 kilometers of road networks in Victoria and about 4 million drivers that exist in their system. Now they have about 4,000 roughly sketch sites. So the sketch site is a traffic site that I showed you before. They have about 4,000 of them across Victoria, and the system managed that. They call it, ironically, Sydney Coordinated Adaptive Traffic System. So it's actually developed in New South Wales in the 70s actually. So it's been operated in Melbourne over the last 40 years. So the system is very out of date. In fact, lots of programming language that they use in this system now no longer exists. A lot of people can't understand it. Essentially, there's no proper way of utilize this system as improving it. So, and we have, in average, in each of these sites, we have about 5 to 10 detectors or the loop detector. So in total, we have about 20,000 detectors. And the data have been recorded every cycle time, over 24 hours a day. And there's a range of data that have been recorded, okay? So if you roughly do a back of envelope calculation, it's about 3 million data entry per day. And they've been recorded in the last 10 years. So compared to astrophysics, I think this data is a very baby data. But in the sense, it represents quite a huge amount of data from the traffic operator point of view. And the bad news is, or the good news is for us, is that they haven't been in no near to actually utilize this data, okay? So they absolutely have no resource and expertise and time to actually doing anything with this data. And as Matthew rightly put, data is oil. So we want to tap into it and get something good out from this data and serving back to the community. So this is the kind of research that we are doing here at the moment in full swing. So we essentially categorize that into 3 different categories. The first one is for network operators, so serving directly to people like VicRoad. So looking at kind of monitor performance improvement and coordinate this kind of traffic light in the networks, which is a very complex problem. It is complex because my background is computer science and electrical engineering. We used to design and develop algorithms for computer networks, which is already very complex. But the inherent complexity in this network is also because we have human in these networks. Okay, it's not like data or packets in data network where we can just telling them what to do. Here we have human to dealing with, which is very different aspect into the problem. We're also looking into supporting users. So you obviously heard a lot about that. We have a lot of online tools nowadays to predict the traffic, giving you the condition of the network before you travel and so on. So this is kind of supporting system for the user. And finally, we're also looking after the infrastructure and the data analysis side of it. So that is a kind of thing that we are doing. And listening to one of our speakers from Social Research Institute, I'm thinking of that this is very close to also the urban plan and development kind of thing as well, because traffic is what appear when you actually have development and this kind of planning, that how you plan the city and so on. We need to take into account that how you manage the traffic and the transportation around it. So this is a kind of output that we have produced. We have been very grateful to the support of Swinburne Research and a range of people who are here as well in this room in terms of support of our research. And even though our existence is only in the last 2 years, we've done quite a substantial amount of research. We are now known as a group in Australia, as an active group in intelligent transport system. So this is a kind of visualization that we have done in our group, showing that how traffic congestion occur in the grand final football in Melbourne, for example. So we can show that where is the hotspot just after grand final. This is another thing that we're doing. We're sourcing Twitter data about incident and so on in the networks, and we at the moment with our own money maintain a website where people can access to it online and looking into that what's happening in the network at the moment based on all of the information that people tweet about, that there's a road closure incident and so on. So this is we develop it and we maintain it we host it in Amazon and we pay it monthly on our money to actually in one way is to collect the data, because this is how we collect the Twitter data. Another way is to demonstrate or to essentially give it as a demo for our group research. This is another example where we looking at spatial and temporal clustering of congestion. So this is 8:25 in the morning based on some historical data in 2012. You can see clearly that the data, the congestion is on this south-north direction, but that 5 minutes later, the congestion seemed to shift into this direction. So this is the final slide. So this is our group. Again, I'm grateful for Swinburne Research and Swinburne to support us. At least that is a start, and we are growing. And that's all for me. Yeah,
thanks, Hal.
Do you have data capture for anywhere outside of the CBD?
Yes. So the question was that do we have data capture outside of the CBD? So the data that I'm talking here is only directly related to the SCAD system, the traffic management system, but and this system is cover all the Victoria, so it's not only the Melbourne CBD, but all Victoria. But outside of that, there's many other sources of data that we start to tapping into. So, for example, data from a private company who running this kind of road guidance system. So they have GPS data, so things like that, yes.
Would you be able to reverse engineer journeys, or would you be able to come up with an indicator of typical transport for different urban densities?
Yes, so the question is that can we reverse engineering and come up with some indicator for the networks? So that's exactly one of the projects currently we doing for Vic Road. So they want us to come up with a singular number, singular indicator to indicate the condition of the network or health of the network. So they want to show to the minister, to show to the upper management that this is what we do, and look, over a month this improved that much. Okay, now the problem with a single indicator is that this is a very complex problem with so many influence factors. So something has to give. So we have some current proposal that we can provide a single number, but we have some of the detail been lost in that. So the proposal that we have is that we have that.
Can I just?
Yeah.
So
we do have the solution for it. Yeah.
Sorry, because we need to go to T in a minute. But anyway, I just want to, the focus of the workshop, right, resources and things like this. So how many people do you have working on this? Who pays them? You have a fellowship, I understand. So
currently, the group, in terms of resource, we have a fellowship that I carry. We have one postdoc and a range of member PhD students. I should acknowledge that there's lots of my colleagues are contributing to it as a affiliated member. So they contribute in the sense that they have a project that related to this and working with us. So they are not as a resource as such, but they actually contribute their time and expertise into it. So it's in the sense it's currently a kind of virtual group. Yeah. That's all the resource that we have. We're part of the grant that Yoon mentioned before. We want the space to actually store the data. We cannot store the data in the cloud because of the concern from Big Road. So we need to have some sort of in-house solution where we can store it. And also, currently, we are discussing with a range of different private people who can provide us with their data. But again, this comes back to Peter's problem that different people have very different way of storing the data. We need software engineering. We need someone who are with more expertise in that to actually help us to actually formalize them and then put in the form that we can use. Yeah.
Note that, Matthew? Okay. So we're going to have morning tea now, which will be served out there. Grab your mug, and we'll be back in 15 minutes. Okay, let's thank all the speakers this morning.
This has been a Swinburne production.